Hello everyone, welcome back to my YouTube channel Data Toolkit. My name is Sakshi and in today's module we will learn what is the compute layer. So understand the compute layer in Snowflake is responsible for executing queries and performing data processing tasks. Multiple virtual warehouse can be created in Snowflake. Virtual warehouse is responsible for executing queries, loading data and other processing tasks. User can scale their virtual warehouse both horizontally and vertically. So horizontally is nothing but it is a scale out. We can add more cluster of compute for increase the concurrency. And vertical means scale up. We can increase the size of virtual house to process large volume of data. Each virtual warehouse operates independently. This means that workload from one warehouse don't affect the performance of other warehouse. I will explain this in detail in the later. The main purpose of multi-cluster virtual house is to improve queuing, concurrency querying and concurrent users. The Snowflake provide range of virtual warehouse size extra small to 4 extra large. The next is scaling policy and multi-clustering. So in Snowflake, multi-cluster means a virtual warehouse can add more computing clusters automatically when there is lot of work and reduce it when work is less. We use it to handle big workloads smoothly without delay and to save the cost by not using extra cluster when it is not needed. So there are two types, standard scaling policy and economy scaling policy. So by default policy is standard scaling policy. If you see the document or Snowflake document, they already provided everything in detail. So you can see here standard and economy. So warehouse start and warehouse shutdown. So when it is start, the first cluster start immediately when either a query is queued or a system detects that there one more query than currently running cluster can execute. After 2 to 3, then when it is shut down, so after 2 to 3 consecutive successful check, it will be shut down. Each successive cluster wait to start 20 seconds after the prior one has started. For example, if your workhouse is configured with 10 max cluster, it can take full 200 plus seconds to start all the 10 clusters. Then in economy, you can say only if the system estimates there enough query load to keep the cluster busy for at least 60 minutes, it will start, and when it shut down after 5 to 6 consecutive successful check, it will be shut down. So this is about the scaling policy. If you want more details, you can go through this page. Next is cloud layer and service layer. The Snowflake cloud service layer is a brain of the system which coordinate and manage the entire system. These layer manage all the Snowflake operations including metadata management, authentication, security, optimization and access control. It also handles tasks such as query parsing, optimization and transaction management. These layers ensure that Snowflake remain highly performed and secure across multiple users and workloads. These layers provided different services like authentication, infrastructure management, metadata management, query parsing and optimization, access control. So cloud layer deal with the security at account level, object level and data level. So let's understand. In the account level, it will come SSO and MFA key, that is the single sign on, and MFA key is the multi-factor authentication key, which is provided and increase the login security. And SSO is nothing but user can connect to the Snowflake by using the single sign on. Then it is also provided the object level security, that is the DAC and RBAC. So DAC is nothing but the discretionary access control, and RBAC is nothing but it is role based control access. So in the DAC, each object has an owner who can in turn grant access to that object. So we can grant the access and we can also revoke the access. In RBIC, access is through the roles. So roles are granted privileges and then the roles are granted to users and other roles. So which we already covered that 6 roles in our previous module. Then if we talk about the object security, so Snowflake provide the control over access to object, who can access what object, what operation can be performed on those object, and who can create or alter the access control policy. So it is also provided the data security, column level security, dynamic data masking. So it is provided the data masking is nothing but while accessing the data from Snowflake table, data will be masked after the loading. So this is all about the cloud layer. So next is why we need data warehouse in real-time project. So guys, let's understand this is more important. So for example, we have a multiple teams like HR team, sales team, customer service team and engineering team. So they want to access particular data from data warehouse. So what we need to do, we grant everybody, but there will be concurrency performance issue if grant for everyone. Okay. So if HR team is accessing same data which is modified by the another team, for example, sales team is modifying that same data, then it will create a mess. So that's why in traditional system, every team has a separate data marts because they don't want anyone can see the data and put the data, that data into the data mart in data warehouse. So that's why we have created everywhere this data mart. Suppose there is HR team, then there will be the data mart for the HR team. If there is a sales team, then there is a data mart for the sales team. Same for the customer service and engineering team. So if we are creating the data marts, then we don't know in which data mart latest data. So if both the team want same data and if I am creating separate data marts, then there is a chance duplicate data will be created and storage will be wasted. Suppose if HR team and sales team want both the data, same data, then there will be the duplicate. So what Snowflake are doing here, they are placing all the data in single place and they are created separate data warehouse for separate team. So each team have the separate data warehouse. So here we no need to create the duplicate data, no need to worry about the data. So this is possible only in the Snowflakes. That's why we are using multi-cluster data warehouse. And suppose if you want to increase the query performance, you can increase the size of data warehouse. And if data warehouse size is small and if you want to learn multiple queries, then it will wait in the queue state and you have to wait. So this is the advantage of the Snowflake. Next is query execution process. So let's understand what is the query execution process. So if any query is executed, it stores the particular result for 24 hours and within a 24 hours, if any user runs same query, then it will be automatically fulfill the query result from the result cache. So it won't go to the database and data warehouse. So if any query executed, Snowflake first check it is available in the result cache or not. So if we trigger any query, then Snowflake check in the cloud layer, and if cloud service layer uses more than 10%, then it will charge. So this is about the query execution process. Now we will talk about the interview questions. So the first interview question is on the layers is, what happened to the storage of a table when it is cloned in Snowflake? So when a table is cloned, Snowflake uses zero copy cloning technique, meaning no additional storage is used initially. Both the original and the clone table share the same underlying storage, with the new storage only allocated for modification made to either table. Second question, how does the cloud services layer ensure metadata management in Snowflake? So Snowflake Cloud Service Layer maintains the metadata such as table, schemas, query execution plans, and optimization details. It ensures that metadata is always up to date and accessible to provide the fast query execution, efficient storage management, and scalability. Next question is, what are the benefits of Snowflake separation of storage and compute? The separation allows for the flexible scaling, meaning storage can grow without increasing the compute resources and compute can be scaled to handle the high query load without impacting storage cost. How Snowflake charge? The number of virtual machine used and how long they run and the size of the run. So on this basis, the Snowflake charge. Next question, what is the primary purpose of multi-cluster virtual warehouse? So primary cluster is improved queuing, concurrency querying and concurrent users. Then last question is what is the pruning? So I already covered this question. So through the metadata, Snowflake can skip unnecessary micro partition during the query execution and improve the performance. It's called pruning. Guys, if you feel this video is informative, please like, comment and share my videos. If you are new to the channel, please subscribe my channel Data Toolkit. Like the videos to show your support and comment below with your thoughts of the questions. So we love hearing from you. Thank you for watching my video. Keep learning and growing.